And now, it's a great honor and great pleasure for me to introduce a Canadian colleague, G. Mark Richardson. He holds a PhD in biology from the University of Ottawa. He has more than 25 years of experience in risk assessment of human exposure to substances in the environment and from medical dental materials. Mark joined SNC-Lavalin Environment in April 2010 as team leader for risk assessment to establish a center of excellence in risk assessment with that company. Mark was the author of Health Canada's 1995 risk assessment of mercury exposure from dental amalgam and has continued to investigate and publish on various aspects of dental amalgam safety since then, including potential occupational risks to dentists. He is also the author of the only assessment published in North America on exposures and risks posed by composite resin dental materials, including bisphenol A. Ladies and gentlemen, please give a warm IMT welcome, and please listen dearly to the important information that Dr. Mark Richardson will be presenting. Mark.
There, am I coming through okay? Great. It's kind of hard to follow that introduction. I did meet the other Dr. Richardson yesterday, also from Canada, also equally good looking. And it was very nice to see additional Canadian colleagues in the mix. I always enjoy coming here because you're probably the only people who are actually interested in the work I do. Am I coming through too loud, or you guys can, because I can hear a bit of feedback. Anyways, I'm going to talk a little bit about the risk assessment I did recently. Back in December, the FDA had hearings on amalgam as a dental material, and they were gracious enough not to provide any funding, but if a risk assessment got done in time by about the middle of November, they agreed that they distribute it to all the panel members. So we worked very hard with the assistance of IAONT and some other funders to get that work done, and that's what I'm going to talk to you about today, is the work that we did that the dental panel received. Very good. Just as a bit of outline here, just as a background, some historic uses of mercury, which you're probably already familiar with, regulatory perspectives on mercury. A little bit about what risk assessment is. I often say risk assessment is not difficult. It's not rocket science. It's very straightforward. It's very logical. And when it comes to mercury and dental amalgam, I just think I was the only person silly enough to actually try it because it had been done at least 13 or 14 times before I did the work in '95. It's just nobody had done that comparison. They knew what the doses were. There were numerous estimates of those doses. They just never bothered to compare it to a level of exposure or a dose that you might consider safe, or a reference exposure level, as we often call them, or REL. So I'm going to talk a little bit about those reference exposure levels for mercury vapor and weight of evidence for toxicity and that sort of thing. How is exposure calculated? I'll prove to you that it's really not that difficult. I'll show you how I did those calculations, give you some idea of current exposures, and also figure out just how would you go about calculating the safe number of fillings or amalgam-filled surfaces that people could have, assuming that there could be a safe number, recognizing different opinions in the room. Some historical perspectives on mercury, of course. They've been used in pesticides. The most mercury-contaminated land in the United States, probably in North America, are Gulf greens and Gulf teas that were treated with mercuric-based pesticides for decades. Prevent snow mold from forming after the snow melted, to keep earthworms out of the greens that would interfere with putting and a number of other things. The US EPA used to have a notice on their website that golfers should not insert the tea and then tee off and then pull the tea out of the ground and put it in their mouth because of the pesticide exposure that could result from that. So if you do that practice, you should probably stop. It may not be mercury-based pesticides now, but they use others. Mercury used to be an additive in indoor latex paints as a preservative. Stop the paint from going moldy sitting on the shelf. Mercury's long been used in the chlor-alkali industry. Probably the most common use and environmental release now of mercury in the third world is use in amalgamation of gold, extraction of gold, gold panning, and that sort of thing. Very rampant in Africa and South America as a major problem and source of environmental pollution. Lighthouses. You go to a historic site, have these lovely tall old lighthouses, and you climb up the spiral staircase to the top, and you see that huge lens, if they're still there. Well, those lenses, in many cases, used to rotate in a bath of mercury, because that was the only thing that could support their weight and allow them to rotate, because they were so large. So most lighthouses, at least in Canada, the old ones, actually have a mercury contamination problem. Electrical switches. I don't know how many people have kids that when they walk, the little lights flash on the heels of their shoes. When those were first introduced, it was a mercury switch in the sole of the shoe. And that isn't very many years ago. It's maybe 15 to 20 years ago. They were imported from China, and they just had a little mercury switch. So as they walked, it would rock back and forth and turn the light on and off. Manometers. Well, you have blood pressure manometers, but for measuring petroleum pressures in pipelines or water levels, you know, for various water bodies where they monitor the trying to maintain a steady level of water in a navigatable waterway, that sort of thing. They used to use mercury-based manometers. They would contain about a half a pound to a pound of mercury, and they tended to have problems, particularly in Canada. The lines would freeze and cause a back pressure and a bit of an explosion, or really remote ones. Hunters used to like to break into the shacks and shoot them. I worked on a project a number of years ago dealing with contamination of water level manometers for government department in Canada. There's been all sorts of medical and dental applications over the years. As a kid, I used to put mercurochrome on my skin when I had a cut, etc. Skin lightening creams still get imported, I know, into Canada on occasion, particularly from Eastern Africa, that have mercuric chloride in them as a major ingredient, etc. And dental amalgams on there. Probably the only use that's left that isn't being phased out now in North America is mercury as dental amalgam. And I'm sure many of you know about the UNEP initiative to phase out mercury uses. It got underway in June of 2010 because President Obama finally withdrew the U.S. veto on any planned program on mercury at UNEP. So he kind of permitted that to go ahead, so they started their first meeting in June of 2010. And there's all sorts of plans, but dental amalgam will likely be exempt. That's the current status or position of Canada and the U.S., I believe, in those negotiations right now. Regulatory perspectives, of course, mercury's on all sorts of lists. It always has been. I ran through this list for the folks at the panel hearings just to remind them. It's been on EPA's list of toxic substances since '78, and that was replaced by their priority pollutant list in '82. CERCLA, I think, is the Superfund program, if I'm not mistaken. So it's number 3 on that list. You have an Agency for Toxic Substances and Disease Registry. What a horrendous name, but it does some great work in terms of tox reviews, etc. It's number 8 on their list. In Canada, we've had it on our list of toxic substances since '88. In 2009, and I've got this and I'm happy to send it around, the Society for Toxicology did a survey of its membership. I think it was related to one of their conferences, but they did this survey through one of the universities in the States who organized it. Mercury was only surpassed as a concern amongst basically professional toxicologists in the U.S. by first-hand and second-hand tobacco smoke and chewing of tobacco. So tobacco was considered a greater concern to toxicologists than mercury, but mercury was number 2. And despite that concern, I'm always surprised at the lack of any effort to reduce exposure when the opportunity arises. Of course, Superfund sites, there's a little over 1,500 Superfund sites. They also call them the National Priority List sites in the States. Almost half of them are contaminated with elemental mercury. And we actually went through an exercise back in the fall where we went through and identified a number of the sites where dentists, dental clinics, or dental materials manufacturers were identified as responsible parties for the cleanup of those sites. So that means they had to kick in some money. Didn't say how much, but they were identified as responsible. Many of those because a particular site had been the place where their dental amalgam waste from their practice went, or the waste from the manufacture of dental amalgam as a material ended up going to some of these sites. Of course, mercury's hazardous. Dental amalgam is a hazardous waste after it comes out of the mouth. I'm not quite sure how it gets there in the first place, but it is a hazardous material, and I've already mentioned UNEP. What is risk assessment? At the top is sort of one of those definitions that comes up in various documents or guidance documents on how to do risk assessment. It really boils down to trying to figure out how much exposure is occurring, whether that be in an individual or a representative, we would call them a receptor, sort of this hypothetical receptor, or in the case of the analysis we did back in the fall, looking at the total U.S. population, and then comparing that exposure to a dose you think that is, for all intents and purposes, considered safe. And I'm not going to get into the debates about whether or not mercury exposure is safe or not. But the rules of toxicology, mean anything. If a substance is not carcinogenic, but it causes various effects, it is generally assumed to have some level of exposure below which you wouldn't expect any harm. And you have to realize we evolved through millennia of exposure to toxic substances, metals in particular, mercury as well. And our systems, our metabolic systems, have evolved to cope with that. That's why we all have metallothionein to bind up metals. It's to remove them from potential contact with our cells where the toxicity might occur. So in general terms, we think that there's some level that you could have. Some exposure could occur without effects. You just want it to stay below or stay within that safe range. And so risk assessment is one, figuring out what exposure is occurring, figure out what that safe level might be, and then just comparing the two. The question is, does exposure exceed that safe level or not? So that's really all risk assessment is. I'm going to talk about these. I'll go back here for a minute. As I say at the bottom, for mercury vapor, risk is exposure divided by the reference exposure level. And if your exposure is less than or equal to that reference level, then you're fine. In theory, you would be fine. We wouldn't worry about it. Regulatory agencies wouldn't worry about it. The question is when exposure exceeds that. Reference exposure levels come by many, many names. I got calling them RELs just for the sake of trying to sort of marry them all together, but they're called reference doses, reference concentrations. Particularly if it's in air, they consider it a reference concentration rather than dose. Minimum risk level, tolerable daily intake, tolerable concentration, acceptable daily intake, reference exposure level kind of incorporates them all. Depends on what agency you work for. If you work for the US EPA, it's a reference dose and reference concentration, RFD, RFC. If you work at ATSDR, it's MRL. At Health Canada, we call it a TDI, tolerable daily intake, or a tolerable concentration, TC. WHO used to call them ADIs. It's really just depends what agency you work for, and somewhere back in history, somebody decided to call them something, and that's kind of stuck. But they all mean the same thing. So the issue with mercury vapor is it generally occurs as a vapor. You inhale it. Your exposure comes predominantly from inhalation. So you have to compare it to, or the appropriate reference exposure level for mercury vapor is as a concentration. But you don't calculate the concentration that people are inhaling from amalgam. We calculate the dose through other means. So then we convert that reference air concentration to an equivalent dose, assuming 80% absorption, etc., so that we can have doses that we compare. I make the point, interesting thing about mercury is that nobody has sued the EPA for unnecessary cleanup of contaminated sites or unnecessary amelioration of stack emissions of mercury. Because if 25 to 30 amalgam fillings are safe, then the reference concentration can probably be 30 to 50 times higher than it is. And I've actually been quite surprised that a electric generation station or a company that generates electricity by burning coal, one of their main problems is mercury emissions, because mercury is found in the coal. And they have to spend millions of dollars, and collectively as an industry, billions of dollars to control mercury emissions. But if the EPA considered the amount of mercury exposure that comes from a mouthful of dental fillings as safe, then they're needlessly spending that money. And I've been kind of waiting for an industry to come forward and challenge EPA on this whole issue, because the level that they say is safe is way lower than the amount of mercury exposure the vast majority of the population gets, and we'll get to that in a minute. I mentioned that reference doses do mean something. When they clean up a contaminated site, a Superfund site, if it's got mercury in it, mercury exposure from that site cannot exceed, at least in theory, cannot exceed the safe dose, that reference concentration for mercury vapor. And then, and the company I work for, we spend, our production work is for clients who have contaminated sites, whether it's mercury or other things. And we're, part of my normal job is to calculate how much cleanup has to be done to ensure that that exposure does not exceed that safe level. And these reference doses and reference exposure levels are used routinely for all of these things, plus many other things. So they're used, they actually mean something. Regulatory agencies swear by them, implement laws, regulations, give permits for emissions and everything else, all based on these reference exposure levels, except when it comes to dental amalgam. And we'll get to, in a moment or two, exactly what a safe level might be. How many fillings could you have and not exceed that safe dose? These are the currently published reference exposure levels for mercury vapor. California EPA says it should be 0.03 micrograms per cubic meter of air. The US EPA says it should be 10 times higher than that. I published one back in 2009 that's sort of in the middle, as is another one by an author named Lettmeyer et al. And the ATSDR is fairly close to the US EPA. These are all different, and it's not because we're looking at different science. We're looking at the exact same science. It's just different agencies have different policies. They have evolved different ways of looking at the data and interpreting it to come up with what's a safe dose. And a lot of it has to do with, we know that we don't know all the information about mercury, so how much precaution should we apply to the derivation of a safe dose? So we start with an average concentration in air that's been affiliated or associated with effects in dentists or in chlor-alkali workers, etc., of somewhere around 30 micrograms per cubic meter. And then you say, whoa, well, how much precaution should I add to that? So the EPA the California EPA thinks it needs 10 times more precaution than the US EPA, and I'm somewhere in the middle. And these are all based on the same science. It's just policy. It's not science, really, that's driving these differences. I just wanted to make that point. When I did my work and published it in 2009, one of the major issues, I'm just going to go back here a minute, the ones that are marked in white here, they all use studies from workers in chlor-alkali plants as the basis for the effects that have been measured, what they think the average air concentration those workers were exposed to, which they then applied uncertainty factors to come up with their reference or safe concentration. The problem is that chlor-alkali workers are concomitantly exposed to chlorine gas, which actually chemically interacts with mercury vapor to produce mercuric chloride, which is not absorbed the same way, doesn't cross the blood-brain barrier, etc. So the point of our publication 2009 was to omit consideration of the studies that California EPA, US EPA, and the ATSDR relied on. And in fact, we used a study of dentists who, I forget how many anyway, in Singapore. And we use that study as the basis for derivation of our basically on behalf of Canada, the reference exposure level that we suggest be used in Canada. The authors, Lettmeyer et al., published a paper in 2010 where they were, I think, one of the first studies since the early 1990s anyways, that did a new occupational study of people exposed to mercury. And they derive a slightly different data. Actually, they give a range of a reference exposure level of 0.07 to 0.1, and I just put in the 0.07. But like I said, that's one of the first recent studies that used the traditional occupational hygiene style or design of study since at least the early 90s, if not before. So we all come up with different numbers, but they're all kind of in the same ballpark. And this is why I don't like using studies of chlor-alkali workers. You have the slides, I believe, but there's interferences with the absorption and tissue distribution and effects that are likely to be caused when you have co-exposure to chlorine gas. I presented this work to the panel, the FDA panel back in December, and actually one of the scientists from the U.S. EPA, I made the comment that you should not use studies of chlor-alkali workers because of this concomitant exposure to chlorine gas. And her response was, that's a red herring. There were only 12 people in the key study that were from the chlor-alkali industry, because that study encompassed more. So 12 people couldn't possibly be important. And of course, when you go back and look at that study, it was 12 of only 26. So almost half the people studied in that investigation were from the chlor-alkali industry. And this whole issue of a red herring, I went through all of the literature that the EPA has published about this on their IRIS database. They have an integrated risk information system that's up online. It's a wonderful database, wonderful resource. And basically came to the conclusion that anywhere between 50 and 90% of all the people considered by the EPA in setting their reference dose of 0.3 were chlor-alkali workers. And in fact, there would be a lot of confounding with concomitant chlorine gas exposure in those workers, and they would have less effects at a given level, or they would require a higher level of mercury vapor exposure to cause the same effects as people who were exposed to mercury vapor alone without that chlorine gas exposure happening at the same time. So this is really just for your own benefit, my response to the EPA's comment that my concern was a red herring. I do not believe it is. And I think most of the reference exposure levels used in the U.S. are inappropriately based on studies of chlor-alkali workers, because they will underpredict the hazard of exposure to mercury vapor. Because most of us don't have that co-exposure to the two substances, certainly not in our homes or in our mouths. Talk a little bit about the weight of evidence. I've got a list here of 20 studies that have been variously reviewed by myself, ATSDR, the EPA, both EPAs, California and the federal, and others, in terms of mostly studies of workers exposed to mercury. The last study, James Wood et al., that's actually exposure of kids who have had mercury amalgam fillings placed in their mouths. And in fact, I have one of my staff right now working on extending this list, because there's at least 50, and there's probably more. I've got work ongoing to extend this. But the whole point here is, it's often said, these workers are exposed to levels far, far higher than people with amalgam fillings, and therefore we don't have to be worried. In fact, the Canadian Dental Association did that calculation that you need 200 or 300 fillings to reach the occupational exposure level, the threshold limit value, and that sort of thing. But the thing is that most of these studies are interpreted, what is the average exposure in the exposed group, and then you try and work backwards, applying these precautionary principles to come up with a safe dose. nobody hardly ever looks at the range of exposure in the exposed group from these studies. So that's all I did, was plot the minimum to the maximum exposure of the workers investigated in these studies, and the numbers at the end of those bars actually relate to the numbers in this slide. And in the vast majority of these cases, exposure of the study group, the group that is exposed to mercury in which they found effects, the lowest exposed person had less exposure than what comes commonly from the average dose from amalgam fillings. So that's what that vertical red bar is. That's kind of the average. If you have amalgam fillings, that's the kind of dose you get. And you can see even these workers have exposure that is less than what comes from amalgam fillings, and they were part of a study group where they found effects due to mercury exposure. The bottom study, where I just have the point, I only have the point added there because that's all that's been reported. But in fact, that dose of mercury, which is very low, has actually been associated with a subchronic effect on the heme synthesis pathway in kids. And in fact, Drs. Mark and David Geyer, I saw them yesterday. I don't know if they're still here. They've done a lot of research trying to improve the analysis of this and further the analysis that was started by James Wood with this study. So, and it's quite, I find it quite disturbing that, nobody thinks about this range of exposure and how it, a group of people who are exposed, they're not all exposed to the same amount. So this will be expanded by about 2 to 3-fold when I have the new staff members just sorting out that data. Okay, the question is, well, does exposure to mercury, I've got, what, 7, how much time do I have left anyways? I realize I'm talking. I got another 10 minutes? Yeah? Okay, good. Sorry, I get talking. You have to forgive me. I lose track of time. It comes with being Canadian and the gift of the gab. The first question you have to ask with dental amalgam, does mercury exposure occur because you have amalgam fillings? And this is only one of dozens of studies in the literature that shows as the number of fillings increases in a group of individuals who've been studied, the mercury level in urine also increases. And you can't get mercury into urine without it first being absorbed into the body. So everybody now, and I must admit, in 1994-95, when I did this work for Health Canada, the Dental Association wouldn't acknowledge or admit that there was mercury exposure. Now it's accepted, and now it's minuscule, it's minute, etc. But mercury exposure does occur as a result of having amalgam fillings. There is a background level that everybody has because you get mercury from other levels. Can I have a show of hands? How many people in the room have amalgam fillings? I know my wife is in the room and she has amalgam fillings. She's got 4. Okay, we've got a few. When you came into this room this morning, you can get there's a device called a Techran mercury analyzer. It's a real-time mercury analyzer. And I've seen cases where it's been used. They put it in a room like this when there's a conference, and it starts at a base level. And as people come into the room and they're exhaling into the room, the mercury level in the room actually rises. And it's because people with amalgam fillings release mercury as a vapor. There used to be a in Canada or in Ontario, a very famous research institute just north of Toronto, community north of Toronto, used to study mercury in fish. And one of the key researchers, every time he walked into the lab, all of the analytical equipment would be knocked out for 2 to 3 days, and they couldn't figure out what was going on until they figured out he had amalgam fillings. And when he had his amalgam fillings removed, it solved the problem. And I know about that because the dentist who removed my amalgam fillings also removed his. And it's very interesting how sensitive some of this equipment is now and how you can see that exposure occurring. So, you fill a room with people with amalgam fillings and the mercury levels in the air of that room will just increase because of exhaled vapor. So we know the exposure occurs. There are all sorts of studies. We documented this very extensively in the report we sent to the FDA. But there are studies showing that there's increased mercury levels in exhaled air as a function of number of amalgam fillings or amalgam load. It's in saliva, it's in blood, it's in various organs and tissues, including, kidney, pituitary gland, liver, the brain, etc. It's found in feces in higher levels. It's in amniotic fluid and cord blood, and it's in colostrum and breast milk. All of this proportionate to the number of amalgam fillings either in the person's mouth or in the pregnant woman or mother's mouth. So we know that exposure is occurring, and nobody disputes that anymore. The question is how much, and is it a risk? And that's the big problem. When I did my study, I approached this very simply, just with a simple 4 equations, really. We know that as you get more fillings, mercury levels in urine go up. So you can actually, there's an incremental increase in urinary mercury per amalgam surface, and it's been published on extensively. It's around 0.1 micrograms of mercury per gram creatinine in urine per amalgam filling surface, per surface. And that's been published on extensively. So we can calculate that incremental urinary concentration as a function of fillings. As long as we know how many fillings people have, we should be able to proceed. You know that mercury, the amount of mercury excreted in urine is going to be a function of that calculated mercury times however much creatinine you produce every day, and that just happens to be a function of body weight. So we can calculate how much mercury is excreted every day for an individual with any given number of amalgam-filled tooth surfaces. We know how much is absorbed because if you excrete mercury, you can actually back calculate which was absorbed in order to have that excretion. And then if only 10% of your mercury is being excreted through urine, and actually 90% goes out through the feces at low levels if you have only 1 or 2 fillings, you can actually reverse that to calculate how much had to be absorbed in order to achieve that excretion, and then you can complete the calculation with the amount of mercury absorbed. That's really all I did. It's very straightforward math. And I'm not even the first one to think about it. It was developed in 1995, published in 95 by Wiener and Nylander, and it just happened to be, just by coincidence, the general approach I'd taken in 94, 95, and I've consistently applied it since. And some of these key variables, number of amalgam-filled tooth surfaces. Well, it turns out the U.S. has this wonderful database, NHANES, and they actually recorded all of that information. Every tooth was coded for the tooth number and the surface, 1 to 5 surfaces and everything, and whether or not it had received dental treatment. You have the increase in mercury per amalgam-filled surface. There's 6 recent studies, virtually all of them in North America, on almost 4,000 individuals in total in those studies. Really good data. Creatinine excreted, body weight of people, well, that came from the NHANES data. That was easy. And then the proportion of total mercury excreted via the urine we knew from the scientific literature. So we were able to do those calculations very straightforwardly. We could actually do this. NHANES is a statistically representative sample of the U.S. population. It looks at 10 to 12,000 people, of which about 8,500, I think, had the dental exam. And we were able to convert that to the entire U.S. population because each individual in that survey is assigned a statistical weight. How many members of the U.S. population do they represent? So we were able to apply that and do calculations for the U.S. population. It's the first one that's been done, and I'm kind of surprised that no one had done it before. This was just the data from NHANES, just to show information we went through. We had a total data set for about 17,000 people because we combined a couple of years' worth of data just to make sure we had lots of data. The youngest individual that had received dental treatment in this data set had some kind of filling, 26 months old. And the previous data I used for Health Canada was around 3 years old, and here it's just barely 2 years old. So people, kids are getting fillings younger and younger, in part because of the diet they're given, or apple juices and that sort of thing that are sweet, causing tooth decay. So you can see for toddlers, one toddler had 72 tooth surfaces in their mouth, had received some kind of dental treatment. And for adults, it was 128 was the maximum. That's right out of the U.S. statistics that are available and very well documented. So we were able to use that data. In terms of this variable B, mercury urine is a function of amalgam-filled tooth surfaces. These are the studies that are available. And in fact, we could distinguish children from adults here, because adults, because they're bigger, their dose for any given amalgam surface, you would, like in my case, you would dilute that exposure into greater biomass. Let's put it that way. So for kids having lower biomass, of course, they're going to have higher mercury levels in urine, because they're not diluting it quite the same way. So we were able to distinguish children from adults, which was kind of neat. We did not have quite enough data to distinguish males from females, but there are some marked differences that we couldn't carry through. Creatinine excretion comes right out of a medical textbook. That's creatinine excretion as a function of so many grams of creatinine excreted per day per kilogram of body weight. And we were able to carry that through. And then we just used data from the literature in terms of the proportion of mercury that is excreted by urine. And that actually, it starts out at about 10%. If you have maybe one filling, about 10% of your mercury exposure excreted in the urine. When you get up to having 100 surfaces, it's closer to 40% of your exposure occurs through urine. So there is that change in how the body deals with it, how it expels it from the body. So we were able to take that into account when we were doing our calculations. This is just a comparison. In 95, the data I had to work with, and in 2010, the data I had to work with. An improvement in the population statistics, like they're post-2000 rather than being from 1970. I was working with number of filled teeth, but this time I did number of filled surfaces, which actually improves the data a lot. There was a huge increase in the available data on increasing mercury in urine as a function of amalgam load. In 1995, I had one study with 80 individuals that were investigated. This time there were 6 studies with almost 4,000 people investigated. So the strength of that data is much better, much more rigorous. In fact, the data on that comes virtually all from North America now. We had body weight data right out of NHANES, and we actually, NHANES, forget what the agency is called that runs the NHANES, but they actually produce the statistical weighting. It's not like we come up with a magic number. They tell us for how many members of the American population that each participant in that survey represents. So we were just able to do the math and do the multiplication and come up with estimates for the entire U.S. population. That just talks about, so you translate 17,000 plus participants from NHANES into 310 million Americans. And they do it all the time. This is not any kind of magic. This is the kind of results we get. It can be presented in a number of different ways. This is a frequency histogram for adults. I've got here scenario 2 and scenario 4, because we went through 4 different scenarios, assuming that all fillings reported were amalgam, that we got down to only about 30% of fillings reported were amalgam, just to see how those differences changed. So scenario 2 is assuming all surfaces are amalgam except for 5 surface fillings. We assumed those were a crown or something like that. But if they had a 4 surface filling down to a 1 surface filling, we assumed it was amalgam. And scenario 4 is only about 30% of that. The report's available actually on IAOMT website if you want to read it. But in all cases, you get some very significant results from that. What we've shown, the red bars, the blue bars, is the frequency. So for any given dose, if you go you go up that bar and across to the y-axis, it tells you how many Americans have that same dose. So it's the frequency of the number of Americans who have the different doses that we are able to measure or estimate. And then what we've done, the vertical red bars are just the safe doses, the equivalent safe doses. So Cal EPA's is the most conservative. It's to the farthest to the left, and the US EPA's is furthest to the right. I use this graph to make the point, I don't care what safe dose you want to pick. We can argue about whether or not we worry about chloralkali workers being included in the calculation of these safe doses. It doesn't matter what number you use. There's an awful lot of people that are to the right of those red bars. And those are the people that exceed a safe dose. So if you use, we go to scenario 4, which is the least conservative. It's the most liberal in terms of assuming people have far fewer amalgam fillings than I think they actually do. So almost 60% of them exceed US EPA's safe dose. 100% of them exceed Cal EPA's safe dose. For the US EPA, 60% of 82.5 million is a lot of people. It's roughly 60 million people. You're coming here to tell me I'm soon?
You're good.
I'm good, okay. So, this was probably the most important information that we wanted to transmit to the FDA and their panel, was this whole issue of the amount of exposure that occurs from dental amalgam. If we were dealing here with a population living near a contaminated site, a Superfund site, and we presented these kinds of results, whoever owned or was responsible for that contaminated site would have to clean up so that exposure was reduced so as not to exceed one of those red bars, depending on where you were. If it was a federal site, it would be US EPA's number. But in the case of dental amalgam, the government requires you to do nothing. So that's why I keep expecting a company that's been told to spend 10 or 20 or $100 million to do some form of cleanup on the basis of mercury contamination. I expect them at some point to come forward and challenge the government on the basis of their claim that there's a detrimental effect. If people with amalgam fillings have no detrimental effect, how could the emissions from a coal-fired electrical station cause effects? I keep waiting for that to happen. So we have a lot of people that exceed these safe doses. For scenario 4, I think it was around 60 million. In the case of this one here, it was closer to 100 million. But it's a very significant component of the U.S. population that has amalgam fillings and that exceeds these safe doses. And that, in effect, is an assessment of risk. And that's how we would deal with it in any other situation. If there's a very high exceedance or a very large proportion of the population that exceeds the dose that's assumed to be safe, something needs to be done about it. And that was the message, I hope, that the FDA and the panel took home from our presentation and the report we've submitted to them. This is presenting the data in a little bit different way. These are all of the other assessments of mercury exposure that have been done. Oh, somebody told me that this was a laser pointer. It's not. Okay. The very bottom one is the results I just discussed. 2 up from that, you see Richardson listed again, Richardson and Allen. Those are the results from my 95 assessment for Health Canada. Everything that is above that on the y-axis were done before I did the work in 95. So we weren't the first ones to do exposure estimates, and many of them are in the same ballpark. We were just the first ones to really compare the exposure to a dose, and that was the only thing we did differently. And the reaction was actually very surprising. When I said you could do this kind of analysis at a meeting in Berlin in 94, you could hear a pin drop. And I was just naively stating the obvious. But it's a very straightforward analysis to do. So in most cases, you see, the exposure, if you look at those horizontal bars, that's from minimum to maximum exposure. The circle represents estimated average exposure. The red vertical bars are the safe doses. Oh, you actually have one that works. Thank you very much. Yes, that's the one I did in 95. This one is the most recent. Mackert and Berlin did theirs in 97. Everybody else was published before us. And so there were lots of these analyses around, just nobody had done anything about it. The other thing I was asked to do, of course, was to calculate how many amalgam fillings would be safe. How many could you have, in this case amalgam filled surfaces, and not exceed that safe dose? And you just change the math around. So instead of solving for dose, if you know what the safe dose is, you can solve for n, which is the number of surfaces, assuming everything else is the same. And you come up with these calculations. Just give me a second here. If you are relying on California EPA's safe dose, which is the lowest, it's 0.03 micrograms per cubic meter, toddlers and kids can only have half a filling, half a average filled surface. An adult could have almost a whole surface. So at most they can have one. If you're relying on the U.S. EPA to define the safe dose, which federally is likely what's going to happen, you could have up to 6 surfaces. So that's maybe 3 filled teeth, if you assume a couple surfaces per filled tooth. And for adults, you could have a little bit more. Adults, because they dilute the dose down, because they have greater biomass than kids. So this is pretty straightforward. We just reverse the calculations. And I have to say, I make this point at the bottom, calculations were employed using non-conservative assumptions. If I had the choice between using a very conservative assumption for each parameter, meaning that would overpredict exposure or reduce the number of filled surfaces that could be calculated, I used the most liberal. I didn't use the most conservative. If I used the most conservative, this would be down closer to 0.1 to 0.2. And I did that, just for the sake of argument. No particular reason other. I didn't want US EPA and panelists claiming that I'd used the absolute most conservative value. But when you can't even have a full surface containing amalgam without, exceeding what the dose that the US EPA claims is safe, that is message enough. I didn't have to put a 0.1 or a 0.2 in there. Just saying it was 0.6 was adequate, and that's what I did with all of these. I should mention that my wife, who's in the back of the room, assuming that there's roughly 2 filled surfaces per filled tooth, she has 4 amalgam fillings. And we just decided, and I had calculated 4 as the likely safe number of fillings back in '95, so she chose not to have them out. Though I know she's got a toothache. Is there a dentist in the room? Anyways, so my wife is just around there, just around that level. Just so you know, there are 3 forms of mercury. Part of our work that we submitted to the FDA was looking at co-exposure to mercury vapor and methylmercury and lead, actually, because they all cross the blood-brain barrier. They all cause neurological impacts by similar mechanisms. And there's this rule in toxicology that if they all act the same way, affect the same target organ, etc., you can't consider them in isolation. And we did an analysis of how many, and it's roughly 120 million Americans daily are co-exposed to those 3 substances through fish consumption or their environment or what have you. Anyways, so looking at the 3 forms of mercury, you have, I keep using the wrong one here. You have dental amalgam produces, 57% of total daily exposure in the general population, predominantly the mercury vapor. You get roughly 32 to 34% of exposure to mercury vapor from fish and shellfish, and then air, water, and soil produce nothing in comparison. So if you think about that, even if you have a contaminated site, a Superfund site, the soil's contaminated with mercury, it contributes so little to daily exposure, it's not particularly significant anyways, not if you have amalgam fillings in your mouth and you're eating fish. But by far, amalgam, if you have amalgam fillings, it's the predominant source of exposure to total mercury in the population. Another thing I wanted to mention just quickly, alternate dental materials. I know at the FDA hearing the issue of bisphenol A exposure was raised as kind of a white elephant. I think that was the term the guy used. And it's been raised repeatedly as an issue of concern, in part to distract attention from dental amalgam and mercury exposure. This is work I published in '99 in terms of bisphenol A exposure from air, food, water, and dental materials. And the horizontal lines at the top are the safe doses defined by EPA and Health Canada. Health Canada sets their number at half of what the EPA and the rest of the world define as the safe dose. And we're well below those exposure levels. I didn't get my amalgams removed and replaced with composite resin until I finished this work, because I didn't want to jump out of the frying pan and into the fire. So this convinced me that if I had to have dental work done, that composite resins were going to replace amalgam in my mouth. And certainly I don't allow, well, when my kids were young, they're on their own now, but I didn't permit amalgam to be used in their mouths either. So I do not view composite resin as a significant source of bisphenol A exposure in the general population. It's not. The exposures are well below what would be classed as a safe dose, and that's the test for risk assessment. I will mention that we've got work ongoing on these. I'd hoped to have it done in time for this meeting, and I didn't get it completed, but with the assistance of some graduate students at the University of Saskatchewan, we're doing risk assessments, and I've got the preliminary work on my desk, and I haven't had a chance to go through it, looking at gold, gallium, glass ionomers, ceramics, base metal alloys for crowns and bridges and that sort of thing. We're looking at resins as Pitt and Fisher sealants in young children, very specifically, because it's a little different composition than composite resins. And then one of the students repeated the analysis of composite resin. And I hope to have that work done within the next 2 to 3 months and off to a journal. Unfortunately, it won't be submitted to a dental journal. I have very poor luck in getting stuff published in dental journals. And as a matter of fact, the first work I did on composite resins, I had submitted to a dental journal, the British Dental Journal, and it was rejected. And then I was invited to make a presentation at one of their conferences. And when that was all over, the editor asked if I would resubmit the paper. And I told him it had already gone to another journal, which is unfortunate, because really that's the audience I would like to reach, but I have very poor luck getting articles published in dental journals, so I kind of gave up. But it does get out there. And the work that I just reviewed that we submitted to the FDA, it's been submitted, and hopefully we'll hear soon, but I can't tell you where it's been submitted for fear they reject it and I have to send it someplace else, right? But I hope to have that published within the calendar year anyways, because it does take some time for peer review and response and comments, etc. And with the work we did on this co-exposure to methylmercury, mercury vapor, and lead is also, it's just on the verge of being sent to a journal. We had to rewrite it into a more terse format, and that's proved difficult. So it will go off fairly soon. So the information will be out there, and this will be written up as a paper as well and submitted as soon as we've got the work complete. And I think that's all. Oh, come on, yeah? Yes, that is all. Thank you very much.